Hi, I'm Greg from Workairtech Technologies, and it's a nice sunny Saturday morning here, and I thought, why don't we do some CO2 testing in a vehicle? So first off, a quick look on the internet. There's a bunch of figures you can find really easily. Outside air should be about 400 ppm, and right now we're at 383, so yeah, pretty much smack on. Inside air, looking at about 1000 ppm for a healthy building. Then at about 2000 is where we start to see headaches, nausea, sleepiness, things like that. And then there's 5000 ppm, which is WorkSafe's 8-hour time weighted average. So what that means is you're not allowed to go over 5000 ppm for 8 hours. So I think what we should do is jump in a brand new Land Cruiser behind me and see what kind of numbers we get. Let's go. Okay, so we're in the Land Cruiser. We've got our CO2 meter set up on the dash. We're going to run the air conditioner on recirculate and the windows up. Now if we get a time reading, it's 11:18. I might just reset that to 11 and then we'll get a nice time reading. So we're at 407 ppm. I've just shut the door and we're starting to rise a little bit already in CO2. So let's go for a drive and see what happens. So we've been driving for 7 minutes and we're already at 2000 parts per million, or 2040 parts per million of CO2, and still going up. Now, that's quite significant because we've only been in the vehicle for 7 minutes and I'm the only person in here. So we'll keep driving and we'll just see how much further we go. So you hear the alarm going off on the meter. That's because we've passed 5000 parts per million. I've only been in here for 30 minutes so far and we're at 5027 parts per million and still climbing. So if we had 2 people in here, I probably would have got to that level in 15 minutes, maybe a little bit more. I'm going to keep driving for a bit and just see how high we go. This meter goes to 9999 ppm, so that's going to be our limit. But it'll be kind of interesting to see if we get there and how quickly we do. So I'm going to keep driving for a bit. So I've been driving for an hour now and I'm at 6,500 ppm, so I'm well over the 5000 WorkSafe allowable 8-hour limit, so get going a bit longer, we'll see. So I've been driving for about 2 hours now, 2 hours and 1 minute I've been in the car, and we're at 9843, 42. I think that's a fair bit. Might stop. Okay, so I thought we'd do the same test in one of our filtered Land Cruisers, just to see what happens with the CO2. I don't expect that we'll see any kind of rise in CO2, but it's worth a try.
Now, one of the differences with this vehicle is it's locked on outside air, and that's because we've got our filter unit plumbed into the air conditioner. So we're actually recirculating air, even though that's on outside air, we're recirculating. But we're also adding in filtered outside air. So that's why I don't expect to see any rise in CO2. But we'll go for a drive, 15 minutes, and we'll see. So I've been driving for 15 minutes and there's been no real difference in CO2. I mean, we climbed up to 600 and we've just hung between 590 and 600 for pretty much the entire time. So putting outside air in is obviously a very good thing to do in terms of CO2. It just has to be managed, it has to be filtered to keep the dust out.
Okay, so what does all this mean? Well, to start with, we did the test in a Land Cruiser, but it really could be any machine. Some are going to be better than others, some are going to be quite bad. It depends on cabin size, cabin ceiling. Some machines have got cabin pressurizers, which are going to help. Some machines have got cabin pressurizers that aren't working. Some machines have got cabin pressurizers, but the cabs are so sealed, they just turn into a pressure vessel, and then there's no air exchange. We're really looking for air exchange in this situation. Now, I think the best way to show this data is to graph it out. Now, we've got 0 to 10,000 parts per million up the side. I've just gone to 10,000 because that's where our meter maxed out at. And then I've just got hours of work across the bottom. So, how does this work? If we were to reach 10,000 parts per million at the end of a shift, and we had a nice straight line, we started at 400 and we go up to 10,000, you'd say, well, that's bad, we got to 10,000, it's above the 5,000 safe work limit. Well, they work on an average, time weighted average, and it's actually an 8-hour time weighted average. Now, some gases and dusts, their time weighted average changes if you're doing a 12-hour shift or if you're doing more than 5 days a week, and then they get adjusted down. CO2 is not one of them, so it's 5,000 ppm no matter how many hours you're doing. Now, in this situation, we would get an average of just under 5,000 because we're starting at 400 and we're finishing at 10,000. So we would get an average just under 5,000, and that's okay. That's fine. We can do that day in, day out. What we could also do is we can change this up a bit and we can have some breaks. We can have a faster rate of climb to represent what we got, and we'll add in some breaks. So I've only actually worked this out for an 8-hour shift, but you'll get the idea. So we reached 10,000 parts per million in 2 hours, which is about there. So we get a line to there. Then I'm going to say I'm going to get out at that point and I'm going to have a break. So we drop back down to 400 and I'm going to have half an hour off for smoko. And I'm going to get back in my machine and I'm going to do another 2 hours. So that will get us to 4.5 hour mark there. Then I'm going to say I'm going to get out again. I'm going to have lunch. So we drop back down and I'm going to have an hour for lunch. To there. And then I'm going to get back in my machine and we're going to climb back up to 10,000 to the end of shift. That's also okay. because when you average that out, I think the number was about 4,700, I think it was, you get through here. So that's fine as well. And the reason why it's fine is because we had some breaks and we drop our exposure. Now, if we use the numbers that we've got and we apply it to a machine as if we were working a 12-hour shift on site, and I'm going to have smoko at 9 o'clock and I'm going to have lunch for an hour at 1 o'clock. And then also, for argument's sake, I'm going to say that my cab never goes over 10,000. In reality, that test we were doing, if I had stayed in the Land Cruiser for longer, it would have kept climbing. But I'm going to say that was our ceiling and that's all we got. So I'm going to start at 6 o'clock in the morning, and by 8 o'clock I'm going to be at 10,000. Then I'm just going to plateau it. So at 9 o'clock I'm going to have smoko. So that's about there. So I'm just going to go flat. When I get out, I'm going to have half an hour for smoko. And I'm going to get back in my machine and operate till lunch. So we'll go at the 5.5 hour mark. I'm back up at 10,000. So the 7 hour mark here would be 1 o'clock. I'm going to plateau that across. And then I'm going to get out. And I'm going to have an hour for lunch. So I'm out of my machine for an hour. And I get back in and I'm going to operate it to the end of shift. So that to there. We're back up to 10,000, and then we're just going to stay there to the end of shift, and then we're going to drop down. Now, using the numbers that we got, that would give us a time-weighted average over that 12-hour shift of about 6,400 parts per million. So then we're actually well and truly over the 5,000 ppm time-weighted average. So there's plenty of information on the internet about the effects of CO2, easily researchable. I hope this makes sense, and I hope it's been of some benefit. Appreciate your time and thanks for watching. Cheers. Hey, sorry, I forgot a couple of things. I didn't put on there our Land Cruiser, the filtered one, and that one had 600 parts per million right down here. And that's important because one, not only is it below the 5,000 ppm time-weighted average, but it's also below the 2,000 parts per million, where we know fatigue starts. It's also below 1,000 parts per million, which is where we want our indoor air quality to be. So we're in a really good space right there. So if you've got a cab where you're getting sleepy, this potentially could be your problem. If you've got driver safety systems that are seeing your operators have micro sleeps, again, this could be your problem. Okay, thank you. Bye.